Before we begin learning about the details of C++ programming language, we should review relevant computer science concepts. It's nearly impossible to understand what programming or coding actually does if you don't understand these concepts. Chapter 1 gives a great introduction, so let's get started. This chapter has 11 objectives that you'll be introduced to. And while many of you have studied some of this information in previous courses, some of you are not a computer or information major, and this may be new to you. In this chapter, you will learn about different types of computers, explore hardware and software components, learn about the language of a computer, learn about the evolution of programming languages, examine high-level programming languages, discover what a compiler is and what it does, examine a C++ program, explore how it is processed, learn what an algorithm is and explore problem-solving techniques, become aware of structured design and object-oriented design programming methods, and become aware of the standard C++ ANSI ISO standards for C++ 11 and 14. Now that you know what we're about to learn, let's get started. I want you to use your imagination just for a second. What would you do with your computer if you could not purchase software? And what if the computer came without any Microsoft Windows or Apple iOS operating system? What would you use your computer for? Well, you would not be able to do much of anything with it. It would be pretty much useless, like a paperweight. Software is developed with a programming language, and there are many different types of programming languages. All of them have their strengths and weaknesses. In this class, we will learn C++, which is a programming language that is useful for a lot of different programming tasks. First, a brief history of computers. Most early types of computers were mechanical and bulky in nature, and most required human power. The abacus, for example, item number 1, this is the first device used to conduct calculations. It was invented in Asia. It was used in Babylon, China, and throughout Europe until the Middle Ages. Blaise Pascal invented the Pascaline, which is item number 2. It had 8 movable dials on wheels and could add up to 8 figures. Then in the 17th century, that would be like the 1800s, Leibniz device expanded on the Pascaline and treated multiplication like repeated addition using shifting. It could not only add, it could also subtract, multiply, and divide. It looked a lot like the Pascaline, so I didn't include a picture of it. Joseph Jacquard, a French weaver, came up with the Jacquard loom. That would be item number 4. It used holes punched in cards to provide a weaving instructions. The needles would pass through the holes to create patterns in the fabric. This idea later affected machines for mathematics. Then, item number 5, Babbage machine was created by Charles Babbage, often called the father of computers, created the difference engine. It could perform complex operations like squaring numbers. Babbage only built a prototype though. An actual device was not really built until 2002. So be sure and watch the video in Blackboard about this machine. It's very fascinating and it's something you should know. And finally, the Hollerith machine, item number 6. It was invented by Herman Hollerith and was created to help with the U.S. Census. It actually ran on electricity and it used punched cards to store data. Hollerith established the Tabulating Machine Company, which would later become IBM. These are early computer-like machines because they are totally electronic. Early computers were large and required very regulated environments. The rooms had to remain very clean, cool temperatures had to be maintained. So one of the very first electronic type computer was the Mark I. It was built in 1944 as a joint effort between IBM and Harvard University. Punch cards were used to feed data into the machine. It was 52 feet long, weighed 50 tons, and had over 750,000 parts. Next, the ENIAC was built in 1946 at the University of Pennsylvania. It contained 18,000 vacuum tubes and weighed about 30 tons. The problem with vacuum tubes, they go out often, so they have to be replaced regularly. John von Neumann created the design rules that are still in use today for computers. He designed the arithmetic logic unit, or the ALU, the control unit, both part of the CPU, memory, and input and output devices. This design allowed the computer to store programming instructions and the data at the same time. In 1951, the UNIVAC was built and was sold to the U.S. Census Bureau. The UNIVAC is picture number 4. Then, in 1956, transistors allowed for smaller, faster, and more reliable computers. The top picture in number 5 is a transistor circuit board. Because of this, new programming languages were developed like Fortran and COBOL. Soon, integrated circuits or chips, which is the picture number 5 on the bottom, replaced transistors. Chips are even smaller and more efficient, allowing for greater processing speeds. In 1970, the microprocessor was developed. It allowed the CPU to be placed on a single chip. Steve Wozniak and Steve Jobs designed and built the first Apple computer in 1981, and IBM introduced the first personal computer, or PC. Computers continue to get smaller and faster and more complex. We find them in almost everything we use, and the trend is not slowing down. Here are the categories of different computers. We have mainframes that are used for large businesses. We have mid-sized computers that are used in mid-sized businesses, and then microcomputers typically used in very small businesses or as personal computers. The problem is the line between all these categories has begun to blur somewhat over the years. And because some of them, it's hard to tell exactly which category they would fall into. The hardware of a computer includes the physical things you can actually touch. For example, a circuit board that contains a CPU, main memory, and random access memory, or RAM. It also includes input devices like keyboards, mice, or a microphone, and output devices like your screen, a printer, or speakers. We talked about software earlier, but software is the programming that makes a computer useful. You install software onto the hard drive of a system, such as Microsoft Office or Adobe Illustrator. In this class, our software is Visual Studio. Here is a list of hardware device examples: the CPU, main memory or RAM, secondary storage devices, and input-out devices. Secondary storage could include your hard drive. After reviewing the history of computers, it's safe to say we've come a long way in automation since the early days. In our next video, we'll discuss a few more details about the CPU.